Hello, welcome to Chevolution, enriching minds many at a time. Today's topic is pump curves and the details that we can read through pump curves. This is basically a topic for centrifugal pumps, which is the most common used equipment in a chemical industry. What you are seeing on the screen is uh, a typical pump curve wherein uh, all the lines involved in pump curve, which is head versus flow lines, which you can see these are the three lines which are head versus flow. The efficiency curve, NPSH curve are there. This is just for the illustration purpose. One line is missing from the curve. Please share in the comments which is the line which is missing in this pump curve. So if you see these two diagrams, these are not the kind of diagrams that you generally see when you refer to pump curves, but these are generic pump curves. So what does it indicate? What do you understand from these curves? So if you see on the left hand side, this is head and this is flow. So this is basically head versus flow curves for a family of pumps. So there are multiple pumps HCM 3225 up to HCM 180. Uh, this number indicates inlet and outlet flange sizes in mm. So HCM 180 means the pump has a inlet nozzle of 4 inch, that is 100 mm, and outlet nozzle of 80 mm, that is around 3 inch. So what does it actually indicate? If you see this curve HCM 180, it starts somewhere here. So if you see the head versus flow part, it starts from around 15 meter cube and it reaches up to around 100 and 130 meter cube. So you can use this pump in this particular range. Now this block represents that you can reduce the impeller size and go up to this value, and you can still use this pump. So in the area which is shaded by white marking, whenever your head flow combination is in this particular region, you can use this pump. So this is a generic pump curves wherein you can select the model number of a pump based on your requirement. This is same kind of pump curves. These are of KSB, renowned pump manufacturer. So these are not some different diagrams, but pump curves only. Now this is a specific pump curve. If you see, you can see one pump of 32 to 50. So this indicates basically flange size and a impeller diameter, maximum impeller diameter, which the pump can have. There are various ways a pump can be numbered. This is one of the way wherein the flange sizes and impeller diameters are denoted. So this is CPK 32 to 50, which is a KSB make pump. Uh, if you can see, you have multiple uh, curves here, different from the previous diagram. What we generally refer to is this curve, which is a head versus flow curve, but other two pump curves are also important and uh, uh, they give a lot of information regarding the pump. Now, if you can see, there are three or four lines here. So what does it indicate? On the right hand side of it, you can see there are numbers written like 260, 240, 220 and 200. These are impeller sizes in millimeters. So a same pump can be fitted with different impeller sizes and you can have a different head versus flow combination. This is used whenever you need a lower duty point, lower head and flow combination compared to your standard impeller size. For example, this pump, if it needs to be used for a flow of say around 70 meter cube, then this will be highly oversized. So if you want, sorry, for 70 meters, if you select this head, this will be highly oversized. So you can trim the impeller and select this one. So you can get a head of around, say this is 70. You can get a flow of 10 meter cube per hour at a head of uh, 70 meters. So how do you read these curves? Uh, you have to select any flow. Maybe you need say 15 meter cube per hour at 50 meter head. You just trace it vertically till you reach the horizontal line of 50. Yeah, here. Then you can see that okay, this is a operating point where I can use this impeller size for this head and flow combination. Now, what are the other details that are there in the pump curve? There is another part of efficiency. So you can use this particular pump right from say 5 meter cube to up to 20 meter cube. But it operates at highest efficiency at this particular point. So there are curves also in some manufacturers graphs, and there are numbers printed in some manufacturers. So these basically are the numbers wherein you can know the efficiency when you operate this pump at particular operating point. Okay. And if you see, this line does not touch the x-axis. This line is always ending somewhere below above zero. So what does it indicate? This is end of curve. This is the end of curve. It means if you run this pump above this particular value, you will have a flow so high that current drawn will be very high, and the heat generated because of that high current will damage the pump. So these are the points wherein you can use the pump, but after this, higher flow over this value is not recommended. Okay, this is now the curve which is used for NPSH. This is NPSH required. NPSH available will be calculated from the system, from the elevation of liquid height to the eye point, then your vapor pressure of the liquid and frictional losses. We will have a separate video on calculation of NPSH. But if you see, whenever the flow is higher, the NPSH required is higher, and uh, you can draw a line vertically. So for example, this is your operating point. You can draw a line vertically downward, and this you can see that this is your NPSH required. So this pump will need this much positive head to actually work without cavitation. Now the third part of it is basically power requirement. If you can see, the power requirement is different for different impeller sizes, because once you change impeller sizes, your head flow combination changes, which you can see in the first curve. So for a lower impeller size, there will be lower head and lower flow, and thus the power consumption will be lower. This is useful in selecting the motor horsepower based on your impeller sizes. So if you are using a lower impeller, you will get a lower power requirement, and you can use a smaller motor. Yes, the question which I asked during the initial part is, one line is missing from this, and that is efficiency line. So in some curves, the efficiency curves are marked like this, where you can see the efficiency on the same curve, or if, you can have a different efficiency lines in a separate curve. Okay, I hope you enjoyed the video. If you have any questions, please share in the comment section. Thank you.